Alright, this video is going to be on multiplicity of zeros for a polynomial function. So, quick review. What is a zero of a polynomial function? If I draw a quick sketch of a graph, let's say that we have something like this, and then it hits and goes up right there. So let's say we have an x-intercept here and an x-intercept here. Remember, zeros of a polynomial function are going to be x-intercepts. So zeros are synonymous with, I don't know why I drew a colon, but zeros are synonymous with x-intercepts. Okay, and so where you see an x-intercept, we call those zeros or roots or things like that. The numbers that would cause the y value to be 0. And so in this graph, you can see two x-intercepts. At the first x-intercept, it passes through the x-axis, so passes through. And at this x-intercept, it touches the x-axis and turns. It's a turning point. So we just say it touches the x-axis and turns, touches and turns, and doesn't actually pass through the x-axis. Just hits it and moves on in the opposite direction. And so multiplicity of zeros allows us to know what the graph is going to do at the x-axis. So for this x-intercept here, where it passes through, this one has what we would call an odd multiplicity, or that its zero or factor in the polynomial function occurs an odd number of times. And this x-intercept occurs an even number of times, or repeats an even number of times, and causes that graph to bounce up like that. So what am I talking about? What does that look like? Let's take a look at a function such as this. Let's take a look at, I'm already got it factored because there's other videos on how to factor. So let's say that you have f of x equals x times x plus 4 times x minus 2 squared. So let's say we wanted to make a quick sketch of this graph. Well, I'm going to be able to do that based off of a couple of things. All right. First, I can notice the degree of the polynomial. This is a 1 on that, and this is a 1 on that. If I add up all the exponents, the degree is 4. So since the degree is 4, okay, that means it's even. And if you look at the way the problem is structured, the leading coefficient, if we were to multiply it all out, would be a positive 1. And so it's positive. So even and positive means that the arrows should point up in both directions. The next thing is that if I were to ask you what the zeros are, hopefully you've watched the video on solving by factoring, you take each one and set it equal to 0. So x would equal 0. When would x plus 4 equal 0? When x equals negative 4. And this one would be when x equals 2. So I'm going to put x-intercepts at all of those spots. Okay, so at negative 4, we've got an x-intercept. At 0, we've got an x-intercept. And at 2, we've got an x-intercept. And so what I'm going to do is I'm going to state what the graph's going to do at each x-intercept. Based off of this 1, that's an odd number of times. So if it occurs an odd number of times, I know that this guy will pass through the x-axis. Okay, same thing here, odd number of times, also pass through the x-axis. However, 2, based off of the exponent of 2, that means x minus 2 is written twice. We just write it as x minus 2 squared. That means it occurs twice. And so therefore, that's just going to touch the graph, touch the x-axis, and turn in the opposite direction. Okay? And so if we take a look at what this graph could look like, I know that it has to start up here. So it starts going in that negative 4. It's going to pass through at some point it's going to have to turn so that it can go through the x-intercept of 0, because we know it has to be an x-intercept, but it's also going to pass through. Then it's going to have to turn again in order to hit that third x-intercept. But when it gets to that x-intercept, it's going to not stop, but it's not going to go through the x-axis. It's just going to hit the x-axis and turn up again. And so now we have a sketch of a graph that we can draw based off of end behavior and based off of the multiplicity of zeros. Let's take a look at what you could do maybe to write a function, because there might be a problem like that that you may have to deal with. So let's say that somebody said write a polynomial function where the leading coefficient is positive and has zeros at, let's go with 3, 4, and then let's say 2 with, and let's say with multiplicity of 2. Okay, and so now what we have to do is we have to write each one as a factor. So f of x would equal, and we'd write x minus 3 as a factor, because that would be 3 minus 3 would go to 0, so it'd be a 0. And then x minus 4 for the 0 of 4, because 4 minus 4 would be 0. And then when we get to this 2 with a multiplicity of 2, this is just going to be the exponent on my parentheses. So it would be x minus 2 and then squared. And if your teacher is a fun and kind teacher, you will have to actually multiply this out. This would be considered factored form, but they may want it in standard form. And so you would have to multiply it out. So let's start by multiplying this stuff out. So that would get me x squared, and then minus 4x minus 3x plus 12. And then this one's actually x minus 2 times x minus 2. And so to FOIL that out, you'd get x squared minus 2x plus 4, right, if you FOIL it out. Combine some like terms in each one, so you'd get x squared minus 7x plus 12 times x squared minus 4x plus 4. And now you're going to have to FOIL some more. Well, not FOIL, but you're going to have to multiply it out. And the way you do that is you would multiply everything in the first by everything in the second. So this x squared is going to get multiplied by every single thing over there. So it'd be x to the 4th minus 4x to the 3rd plus 4x squared. And then you're going to do negative 7x gets multiplied by everything. So I'm going to multiply negative 7x to the 3rd plus 28x squared minus 28x. And then you're going to multiply 12 by everything, and you're going to get 12x squared minus 48x, and then plus 48. And then I'm going to add down all the like terms together, and you'll have your final answer. So f of x would equal x to the 4th minus 11x cubed. That'd be 44 plus 44 x squared. Oh my goodness, that would be 6, carry the 1, minus 76x plus 48. And that would be how you would write a polynomial function when you're dealing with some multiplicity. All right, have a great day.